Let's talk about one of the unsung heroes of electronics, the capacitor. You've seen them, those little cans or ceramic discs on circuit boards. They might look simple, but they're fundamental to making our gadgets work. Think of capacitors as tiny temporary storage tanks for electrical energy. Unlike batteries, they don't generate power. They grab it, hold it briefly, and release it in a quick burst. This ability to charge and discharge rapidly is their superpower. Imagine needing to fill a water balloon fast. You'd fill a bucket first, then dump it in. That's what a capacitor does with electricity. It stores up charge, then releases it all at once when needed. Understanding capacitors unlocks a whole new layer of how your gadgets work. Once you get what a capacitor does, you start to see the elegant engineering behind everyday tech. Let's dive in and build that understanding together. So, how does a capacitor actually work? It's surprisingly simple. Picture a sandwich. Two metal plates are the bread, and the filling is an insulating material called a dielectric. When you connect a battery, one plate gains electrons, negative, the other loses them, positive. The dielectric keeps the charges apart, storing energy as an electric field, like a stretched rubber band. The more charge, the more energy stored. When you connect a circuit, the stored energy is released in a quick burst. This charging and discharging happens in a fraction of a second. The size of the plates and the type of dielectric determine how much charge it can hold, measured in farads. Most capacitors in your projects are tiny, but the principle is the same. It's a simple, elegant system, a sandwich that stores and releases energy on command. That's the kind of engineering that makes electronics tick. Let's see where these show up in real life. Now let's spot capacitors in action. Take a camera flash. After you snap a photo, it takes a second to recharge. That's a capacitor charging up. The battery slowly fills the capacitor, which then dumps all its energy in a split second for a bright flash. This turns a trickle of power into a flood, perfect for that burst of light. But capacitors also smooth out power in your phone or laptop. Wall power is bumpy. Capacitors act as shock absorbers, storing energy when voltage is high and releasing it when it dips. This keeps the power steady for sensitive electronics. Think of them as dams, releasing water at a steady rate. Without these smoothing capacitors, our devices would be unreliable. They're the silent guardians of our circuits. Let's compare them to another key component, the battery. People often confuse capacitors and batteries. They both store energy, but in very different ways. Think of a capacitor as a sprinter and a battery as a marathon runner. Batteries store lots of energy chemically and release it slowly, great for endurance. Capacitors store less energy, but can release it almost instantly, perfect for quick bursts. A battery powers your remote for months. A capacitor fires a camera flash in milliseconds. They're not competitors, they're teammates. In many circuits, batteries provide steady power while capacitors handle quick surges and smooth out voltage. The battery runs the marathon, the capacitor sprints when needed. Understanding this difference is key to mastering electronics. One is for longevity, the other for instant power. Both are essential tools in your electronics toolkit. Now let's see why capacitors are everywhere. Capacitors are everywhere because they're fast, smooth out power and work with batteries. On a circuit board, they're like water towers and shock absorbers performing critical background tasks. They're perfect for timing circuits. Pair one with a resistor, and you get a predictable pulse like a metronome for electronics. Every blinking LED or clock cycle in a computer likely relies on a capacitor. They're also crucial for filtering signals in audio gear, blocking DC, and letting AC signals through or separating treble from bass. In radios, they help tune into specific stations by filtering frequencies. Capacitors are the gatekeepers of the electronic world. Here's a challenge: next time you find old electronics, open them up and spot the capacitors. Look for the little cans and discs, count them, and think about their role. Are they smoothing power, timing, filtering? Seeing these hidden components is the first step to understanding and building amazing things. That's the magic of capacitors.